All right, now we're going to look at the graph of the tangent function. So tangent, it says here, is the slope of the terminal side. Well, let's think about what that means. So if I think about a point on my unit circle, I know that the x value corresponds to cosine of theta, and the y value corresponds to sine of theta, if theta is my angle from the x-axis. So when I think about tangent, I know that tangent is sine over cosine. Well, if I think about sine over cosine, if I think about this line, the sine value is how high I went up. The cosine value is how far we went over. So that's the same as rise over run. So whatever the slope of this line is, it tells me what my tan value is. So let's think about taking a line and our different angles. So when we start with an angle of 0, then we've got our line starting this way. This horizontal line has a slope of 0. So when my angle is 0, my slope is 0. Now when we have, let's say, 30 degrees, our slope is going to be 1/2 over root 3 over 2, so 1 over root 3. So at 30 degrees, if we call this 30, we have a very small slope. So let's think about what that's going to be. Got 1 over root 3, and by root 3. So just over 1/2. I know at 45 degrees, that's when my tan value is 1. So here's 1. At 60 degrees, I'm going to have root 3 as my tan value. So root 3 is about 1.8, I believe. 1.7, all right. So 1.7 is going to be somewhere up around here. And then at 90 degrees, so once I have a vertical line at 90 degrees, that has an infinite slope. We end up with an asymptote. As we get closer and closer to 90 degrees, if I think about having an angle of, let's say, 80, this has a very steep line. That slope is positive and a very high number. So let's figure out what it is. I've got, let's check my mode. All right, into degrees. So tangent of 80 degrees is a number much bigger than 1, 5.5, doesn't even fit on my graph, way up here. So I can see that from 0 to 90, the slope is just getting steeper and steeper and steeper. As soon as we cross over 90 degrees, now our slope is very steep again, but is now negative. So after 90 degrees, I have a very negative slope. At 120, I'm going to have negative 1.7. So there's my 1, there's my 2, so negative 1.7 will be somewhere around here. At 135 degrees, that's when my slope is going to be 1. At 150 degrees, I'll have my just over 1/2. And then at 180 degrees, I've got a horizontal line again, so my slope is 0. Now we know as we get into quadrant 3, tangent is positive again. That's because this slope is positive. And we're going to keep being positive and more positive, getting steeper and steeper as we come down until we hit 270 degrees when our slope is infinite again. So as we continue going over, we're going to have another asymptote. and our graph will be just greater than 1, at 1, 1.7. So our tangent curve, and it's still a curve, is going to look something like this. It's very similar to a cubic curve. So we can see that it's repeating itself. I would have another asymptote over here, and my curve is going to go something like this. So I can see from this picture that the period of tangent is pi, or 180 degrees. There is no max and there's no min, because it goes on infinitely in both directions. And therefore there's no amplitude. The only thing we have similar to sine and cosine is the idea of period, and even the period for tan is half the period for sine and cosine. So notice that my asymptotes are at multiples of 90, or if I'm thinking in radians, I've got pi over 2, 3 pi over 2, negative pi over 2. So I have the odd multiples of pi over 2, where when I'm talking about the odd, I'm talking about the numerator value. So there's our basic tan graph.